In this video, we'll take a slide aside from physics and discuss a very important part of mathematics called the dot product, which we will need in order to calculate the important quantity called work. You have two vectors, A and B, and I've attached them by sliding them around so that their tails touch, and you can see that their heads point out like this. And there's an angle that is a small angle, theta, as compared to the outside angle, which is greater than 180. So by theta, I mean an angle, the closest angle that's less than 180 between the two vectors. Now, multiplication is much more complicated in vector land than it is in scalar land. When you go 2 times 3 in scalar land, you mean to add the number 3 2 times. 3 plus 3 is 6. And the result is a scalar. We've already seen that there's one type of multiplication where you take a vector and you multiply it by a scalar number. And this can change the length of the vector, and if it's positive scalar, then it doesn't change the direction, but if it's negative, it rotates at 180. There are at least 2 other types of multiplication of vectors that are important in physics for your level, one of which is called the dot product, or scalar vector multiplication, in which 2 vectors are multiplied together and you end up not with a vector but a scalar number. And then there's also what's called the vector or cross product, in which 2 vectors are multiplied together and you get a third vector that's perpendicular to the first 2. We'll talk about that one later on when we get to rotation. Today we're discussing the scalar vector multiplication, in which 2 vectors are multiplied and you get a scalar number. Or, because of the way it's written in symbology, it's also called the dot product, or sometimes it's even called the inner product. And we'll see why all that is today. In order to distinguish the various types of multiplications, we have to have some notation. Our notation is going to be this. It's the first vector and the second vector. But when we want to do this type of multiplication, we're going to put a dot between them. So the dot doesn't just mean multiply now. The dot has a very specific mathematical interpretation. It means you're going to multiply this vector by that vector and get a number, not a vector. Now we have to give you a formula for computing this number, and the way we compute that number is very simple. Each one of these vectors has a certain length. This one, for instance, has the length A, and you remember that if we leave the arrow off, we mean its magnitude. Or you can also write it with absolute value signs around the arrow, meaning the magnitude. And likewise up here there's some length. I accidentally put something I didn't want on our screen, so let's remove that. It has some B. That's the length B. And likewise we could write an absolute value sign around that arrow. We need to find those 2 lengths, and we need to find this angle between it in order to compute this dot product. And here's the formula. The dot product A dot B is the length of A, the length of B, and the cosine of the angle between them. So this is the magnitude of B. And this is the magnitude of A. All right, so multiply 3 numbers, the A, B, and the cosine of the angle. And that's it, and you get a number. The units will be the units of A times the units of B. So if A is in newtons and B is in seconds, you'd have Newton seconds, although there's no such thing like that in physics. Now, we also want to look at geometrically what the interpretation of this is. So let me draw in this picture and play just some algebra here and show you some things we could do with this. For instance, there's my A. And we also could draw a B. So we'll make that A, and we'll make this B. And if we look at that, there's an angle theta. So we could write this equation as follows. A dot B is equal to A times B cosine of theta. Now, if we do that, what that basically says is that this distance right here is the adjacent side, and that would be B cosine theta. So what we're saying is, take the length of A, this blue arrow, it's length, and multiply it by the amount of B that lies in the same direction. That's what B cosine theta finds you. The amount of B that lies in the direction of A. And that gets you this value. I'm going to give that symbol a name. I'm going to call that B parallel. And by parallel, I mean parallel to A. So this is B parallel. That's one way to interpret this. Let me show you an alternative way to interpret this. If I go ahead and extend the direction of this arrow out like this, then I can think about going back and forming a right triangle here. And this distance right there is A cosine theta. It's the adjacent side of the triangle who has the hypotenuse here. So this triangle with that hypotenuse, this would be A cosine. So it's how much of A lies along B. I'll call that A parallel. So what I'm saying is that another way to have written this was to have rewritten it as A cosine theta times B, and then this part here would have been how much of A is along B. So what the dot product always finds is how aligned two vectors are. If they're aligned basically in the same direction, then it can get to be a pretty large number. So A dot B, whatever this is, has to be less than or equal to the magnitude of A and the magnitude of B. That's when they're both aligned. But it's also possible that these arrows could point in opposite directions. That is, this cosine could go toward 180, in which this would be minus 1. So it could also be minus AB. It can't be greater than AB, and it can't be less than minus AB. If it's negative, it means the vectors are unaligned, that they're more than 90 degrees. And by the way, interestingly enough, if A is perpendicular to B, then A dot B is 0. So this is a way to determine if two things are orthogonal. That is, if they're at right angles to each other. Because if they're at right angles, the cosine of 90 will be 0. So by definition, two things are perpendicular when their dot product is equal to 0. The dot product has tremendous applications in the field of physics, engineering, and mathematics. All I did here in the box is put everything that I said into in the previous discussion. So read it. Let's do some numerical calculations, kind of to finish up this. Let's assume that this maybe was 30 degrees, and this vector here is 5 meters, and this one is 10 meters, let's say, and this is A, and this is B. A dot B would be equal to 5 meters times 10 meters times the cosine of 30 degrees, and you take a calculator and you press that and you get 43.3 meters squared. Notice that the units multiply. And let's see, maybe one more problem. You can also have something like this, where this was 7 meters and it's at 40 degrees, and then you have 6 meters and it's at an angle of 15 degrees, and let's let that be B, and let's let this be A dot B. 7 meters, 6 meters times the cosine, but you got to be careful. The angle that we want is the angle here, which is 40 minus 15, 25 degrees. And punch calculator. You get 38.1 meters squared. Alright, that finishes this video. We'll come back and talk about more about the dot product in the next video.